Hello friends, welcome back to STM Tutorials. Myself Ajinkya and we are here to learn embedded system on STM32F103 controller. So let's begin. In this video we will continue with ADC discussion. So first let's configure the STM controller and its internal ADC. So open STM32Cube IDE. Let's create a new project for our ADC. Click on the file, then on STM32 project. Currently I am using the STM Blueprint board which has STM32F103C8 controller on it. So in the controller section, select the STM32F103C8 controller and click on next. For the ADC interface setting, click on Analog, then on ADC1. As you can see, there are two 12-bit ADC inbuilt in the controller. We are interfacing only single channel of ADC1. So select IN0. As you can see on the right side, PA0 pin turned to green and it is labeled as analog input ADC1 IN0. Now for the LCD interface, we are using PB0 to PB7 pins as general purpose input output. To select the GPIO functionality of the pin, click on respective pin and select GPIO out. It will make the pin configured for GPIO output. We have to do this for PB0, PB1, PB2, PB3, PB4, PB5, PB6 and PB7. For RS and enable pin of the LCD, we will configure the PA6 and PA7 as GPIO out. So following the same steps. Now let's come back to the ADC configuration. There are several parameters to be configured. Some of the parameters are already configured and these are by default set to values or settings. The default configuration for data alignment is right alignment. Means we will get the output from ADC in right alignment. That is, higher 4 bits of the 16-bit data output will be zeros. Rest of the bits will contain the data output. Now, enable the continuous conversion mode so that we can continuously get the converted value from the ADC channel upon pulling. Here, you can see that ADC conversion is set to regular conversion, which is by means of pulling the ADC data. The number of conversions are set to 1, as we have selected only one channel. And the conversion is triggered by the software polling. So whenever we request the ADC converted data, it will provide the SOC signal to internal ADC and we will get the converted data output. Here you can see that the channel 0 is only selected, hence the rank 0. For multiple channels, we can set the order for the conversion. Now if you scroll down the sampling time, there are multiple choices. These choices are dependent on the user and the application. For our project, let's select 1.5 cycles. Now let's go to the clock configuration. We will keep the settings as it is, so no changes are done in the settings. Now let's go to the simulation circuit. For that we have to open Proteus. This is the circuit diagram for ADC interface. You can pause the video and copy the circuit. Now click on Design, click on Configure Power Rails. Here you can see unconnected power nets. Click on VSSA and add it to the ground net. From the power supply's name, you can change it to VCC. Add VDDA to VCC and change the VCC voltage value from 5V to 3.3V. Now change the power supply's name to VEE and change the voltage value from -5 to 0V. Now click on OK. Now let's go to our code. To get the editable code, click on Generate Code under the Navigate tab. Now you will be redirected to main.c file. Just building the workspace. I have copied the LCD functions from LCD interface code. We have to make small changes in it. So this is LCD initialization functions. There are no changes in this LCD initialization function. We have to change the GPIO pin numbers according to our circuit diagram that is shown in the Proteus circuit. The data pins of the LCD are interfaced with the GPIO port B, that is from PB0 to PB7. The RS pin is connected to PA6 and the enable pin is connected to PA7. So we have to make changes according to that. Let's verify that we have made the correct changes. You can cross-verify the pin numbers with the circuit diagram in the Proteus software. Now let's come to this ADC value function. This function is created to display the digital value on LCD that we get from the ADC conversion. Giving the command 0x9c will position the cursor on the third line. To get the most significant bit, we have to divide the value by 1000. This will give the most significant bit of the data. Such as, if 4096 is divided by 1000, we will get 4 as a result. So to display 4, we have to add 48 in it. This will give us the ASCII value for 4. Now, to get the next bit, we have to divide the value by 100 and take modulo 10 of the result. We have to add 48 in it to get the ASCII character value of the same digit. To get the third digit, we have to divide the value by 10 and take modulo 10 of it. And to get the last digit, we have to take modulo 10 of the value. Now coming to the main function. Here we have declared the variables required for our program. While scrolling down, we can see that we have already initialized the GPIO, ADC and LCD functions. Here you can see the LCD initialization function. Now coming to the while one loop, this is our main body of the program. In the main body, we have started the ADC peripheral, we poll for the conversion of the ADC data, and we stop the ADC. In between, we also display the ADC value characters on the LCD. The location given to display these characters is 0x94 and it is provided within the command lcd in bracket 0x94, 0. Here we have started the ADC. Here we call for the conversion by means of software polling. And here we display the value. And after that we stop the ADC. Now let's dump the code into our controller. So double click on the controller, select the hex file and click on OK. Now click on run. The LCD will display certain characters with ADC value displayed on the third line. As you can see, if we go on increasing the temperature, the voltage output will also change. And depending on the voltage output, we get the ADC value. We have just displayed the ADC value. we have not converted this ADC value into voltage. So as we change the temperature, the ADC value also changes. As we go on increasing, the ADC value count also goes on increasing. And if we decrease the temperature, the ADC value count also decreases. This is it for the video. Hope you enjoy the video. If you enjoy the video, click on like, share and subscribe. And thanks for watching the video. See you in the next video.